All right, so this video is going to go over pages 24 and 25 in your packet. So we're going to just do more of the FA minus FF. So FA minus FF equals mass times acceleration. Okay, now that's if we're looking for applied force and frictional force. You could also have problems in here where it's just F net equals MA. So it just kind of depends on the problem, and if you're not given applied force or frictional force and we don't ask for it, then you would just use this F net equals MA. Number one, a jet plane decides to accelerate horizontally if the thrust of the engine increased to 50,000 newtons. Okay, so newtons, that means it's a force. So we got to figure out what kind of force is it. Okay, and it's going east, so we'll kind of keep an eye on that direction. Okay, we're just going to keep reading the problem. So if you're ever confused, just keep reading the problem. We can figure out which one's which. When air resistance acting on the 4,000 kilograms, so there's your mass, amounts to 30,000 newtons westward. So air resistance. So you got to think about it. You got two options. You have applied force and you have frictional force. Applied force is, in this case, it's the thrust of the engine. It's the force that's being applied to the plane. So that 50,000 newtons is your FA. And then when it talks about air resistance, even though that's not like technically friction like on the ground or something like that, like on a surface you would think of, that's still a form of friction because it's trying to slow you down. So that 30,000 newtons is FF. Okay, so what will the plane's acceleration be? So that means you're looking for A. So in this, I know we've been using Daffy T and F equals MA in the mix. Okay, but just don't think that that's going to be every single time. We don't have to make it always two-step problems. If I don't have enough to do Daffy T, or I have enough to actually do FA minus FF equals MA, then just do that. Okay, so just don't think that you always have to do Daffy T every single time. So just make sure you go through your problems and label it and see what do you have and what do you need to do. So we're going to plug in. So FA minus FF, so 50,000 minus 30,000 equals our mass, which is 4,000 times A. So 50,000 minus 30,000 is 20,000, and then divide that by 4,000, and you get an acceleration of 5 meters per second squared, and that is east. Okay, because ultimately you're going east because you had a larger force going east than west. Okay, number two, a force of 36 newtons. Okay, so we just have a force here. We're not going to worry about applied or friction in this case. We're just, until they tell us, we're just going to leave it as F, is given to one mass, M1, and accelerates at 4 meters per second squared. So we're just going to label this A1. The same force gives a second mass, M2, acceleration of 12 meters per second squared. There's your A2. What is the acceleration? So we're looking for our new acceleration. Well, this force gives the two masses if they're brought together. So that means M1 and M2 are combined now. So in order to figure that out, our whole goal is to do F equals MA because we're looking for A. Okay, we have force, okay, but we don't know what those masses are. So what we're going to do is we're going to find the masses of each one. We're going to do these in steps. So remember, F equals MA. So our force is 36 newtons equals mass 1, we don't know. And our acceleration is 4. Okay, so divide both sides by 4, you get a mass 1 of 9 kilograms. Step 2, we're going to do the same thing, but now we're going to use the same force, so 36 newtons. Mass 2, we don't know. And our new acceleration is 12. Okay, divide both sides by 12. And I have a new mass of 3 kilograms. Okay, so this should make sense. As I kind of talked about this in class, if I take the same, like if I were to take a force and push someone that's like my size, okay, I'm going to make them accelerate, but it may not be very fast. Okay, now if I take that same force and push someone smaller, okay, it's going to make them accelerate quicker. Okay, so in this case, it should make sense. If my acceleration is 12 and my force was the same, okay, that means my mass had to be smaller in order to increase speed like that. Okay, so now what we're going to do step 3. So now our masses are combined. We have the same force. We just want to know what is my new acceleration. Okay, so 36 equals my new mass, which is 12, times A. So divide both sides by 12, and I get a new acceleration of 3 meters per second squared. Okay, and it doesn't mention direction at all and stuff, so we're just going to leave it at that. The car is being pushed by 3 ingenious physics students. They know the force of friction of the car is approximately 20 newtons. So there's your FF. The car's mass is 1,040 kilograms. And it is accelerating forward at a rate of 3 meters per second squared. So there's your A. What force are they each applying? So that means you're looking for FA. If they're using equal amounts of force. So always pay attention for underlined words. So we'll worry about that here in just a second. So what we're looking for FA, so we don't know it. Minus FF, which is 20, equals mass times acceleration. So 1,040 times 3. So I would multiply the 1040 times 3 and then add 20 to both sides. And you get an applied force of 3,140 newtons. Now, that's not my answer. That is the total applied force, but I want to know what is the applied force from each of those 3 students. So we're going to divide that thing by 3, and that means each student is pushing with 1,046.67 newtons. Number 4, a 1,200 kilogram car is traveling east. So there's your mass. Okay, east gave me direction, so we'll watch out for that. At a constant speed of 25 meters per second. So again, watch out for this constant speed. So if you're looking for what's VI, what's VF, technically VI would be 25 and VF would also be 25. Okay, if you're going constant speed, is not changing. So what is the net force acting on the object? So F net is your question mark. So you could actually you can try to do Daffy T on this where you do VI and VF, but we didn't give you time. Okay, we don't have acceleration. Okay, you don't have distance, so you can't really do that. The key thing here is constant speed. Okay, if you have a constant velocity or speed, that means acceleration is 0. And if you look at this equation, F net equals ma, and you try to plug in 0 for a, it does not matter what mass is. That mass could be anything. Anything times 0 is 0. So therefore, the answer for this question is F net would be 0. So just watch out for that constant velocity. Okay, next one. I have my car accelerates from 0 to 64 kilometers per hour. So there's VI. Okay, now, remember, if you look at your time, you're in 3.2 seconds, and your velocity is in hours. Okay, so remember we did this kind of a while back, is if you want to go from kilometers per hour to meters per second, just divide by 3.6. So if you take that 64 and divide by 3.6, okay, that's going to give you 17.78 meters per second. So there's my VF. And you know time. If the mass of the car is 2450 kilograms, so there's your mass. And the force of friction is 30 newtons, so there's your FF. What force is produced by my car's engine? Well, if you're given FF, that means the only other force you're looking for is FA. So we know we got to do FA minus FF equals mass times acceleration. So we have FF, we have mass, don't have A. Okay, so what we're going to do Daffy T to help us find that A. So A is your question mark. VF is 17.78. VI would be 0. Time would be 3.2. So that means distance does not matter. So we're going to use equation number 1. So VF equals VI plus AT. So 17.78 equals 0 plus A times 3.2. Okay, so what we're going to do is divide both sides by 3.2, and you're going to get acceleration of 5.56 meters per second squared. Okay, now we're going to take that over to the right, and we're going to plug that in. So FA, we don't know, minus 30 equals 2450 times 5.56. Okay, multiply and then add 30 to both sides, and you should get an applied force of 13,652 newtons. There was no direction, so don't have to worry about putting that in the answer. In number 6, in a physics lab, Mary and Rob are using a hanging mass pulley system to exert a 2.45 Newton force on a 0.500 kilogram cart to accelerate it across the low friction track. If the total resistance force to the motion of the car is 0.72 newtons, then what is the cart's acceleration? So this is what I mean by reading the problem thoroughly to figure out what force is what. So if Mary and Rob are using a hanging mass and a pulley system to exert a force on something, that is your applied force. Okay? If it talks about resistance force, that means that's trying to slow you down. So that means this has to be your frictional force. So if you're ever not sure, just read the problem thoroughly and figure out which one's actually being applied, what's making it go, and what's trying to slow it down. And then I also was given mass, and we're looking for acceleration. So I don't have to do Daffy T or anything like that. It didn't give me anything, so all I got to do is just plug in. So FA minus FF, so 2.45 minus 0.72 equals my mass, okay, which is 0.500, okay, times A. So 2.45 minus 0.72, and then divide both sides by 0.5, and you get acceleration of 3.46 meters per second squared. Now, it did mention a rightward force, so that is your direction. So we're just going to throw that right in there, okay, to make sure we know direction. Number 7, an 1,800 gram cart. Okay, so one thing is you got to be in kilograms. So 1 kilogram equals 1,000 grams. So if you're ever wondering which one to do, okay, you got to think about grams are smaller. So you can fit a lot more grams into a kilogram. So if you were to multiply that thing by 1,000, now all of a sudden you've got you have a lot of kilograms. Okay, so it wouldn't really make sense. It's going to make your numbers very big, which is going to make the problem start to seem weird. Okay, so if you ever figure out if you ever find a time where you're like, this just doesn't seem right, the numbers seem too big, check your conversions. So what I would do is actually divide that by 1,000. Okay, so that means you have a mass of 1.8 kilograms. So there's your mass. Starts from rest, so that means VI was going to be 0. Accelerates through a distance of 1.2 meters, so there's your distance. And in 2.1 seconds, there's your time. What is the net force acting on the car? Okay, so we're just looking for F net in this case. So F net equals MA. So it did not mention applied force or frictional force, so we don't have to worry about splitting that up. So I have mass. I don't have acceleration, though, so we're going to set up Daffy T. Okay, so I know I need that A to cross that bridge. Okay, so VF is going to be, we don't know. Okay, it doesn't mention it. VI is 0. Time is 2.1 seconds. Distance is 1.2 meters, so VF didn't even matter in this problem. So we're going to use equation number 3. So D equals VIT plus 1/2 AT squared. Now, the good news is VI is 0, so this whole VIT goes away. So distance will be 1.2 equals 1/2 times A times 2.1 squared. Now, just be careful with your algebra here. Okay, what I would do is I would go ahead and square 2.1 and then just take half that to get rid of that half, and then divide both sides by whatever that is. So do 2.1 squared, half of that, and then divide both sides by that. And you should get an acceleration of 0.54 meters per second squared. So now I know A, so I can bring that over to my F net. So mass will be 1.8. Acceleration will be 0.54. So multiply those, and you get 0.97 newtons. And does it mention direction? Nope, so I'm going to worry about putting the answer. Number 8, a 2.3 kilogram cart, so there's your mass, is moving at 2.1 meters per second. So there's V, so I'm not going to worry about labeling it yet. We'll do the problem and we'll figure out if it's VI or VF. When a net force of 3.5 newtons, so there's your F net, acts in the direction of the movement, how fast will the car be traveling after 5 seconds? So that means you are looking for VF. You want to know how fast it's going after 5 seconds. That means that you're looking for the future velocity. That means the initial was 2.1, and we're given time. So we're looking for VF. The only thing that has VF in it is Daffy T. So VF is your question mark. VI would be 2.1. Time would be 5.0. But I don't give you acceleration and I don't give you distance. So you don't have enough to do Daffy T. So I do have a force and I do have a mass. So this is what we mean by these things can be backwards as well. You can use F equals ma and then plug into Daffy T, or you could use Daffy T and plug into F equals ma. So those can go back and forth. So I have a force of 3.5 newtons equals my mass, which is 2.3 times A. Divide both sides by 2.3, and you get an acceleration of 1.52 meters per second squared. Now I can bring that over to my Daffy T. So 1.52. That means distance we did not care about. So we use equation number 1. So VF we don't know. VI is 2.1 plus A, which is 1.52 times 5. So all I got to do is just do the simple math there. And we get 9.7 meters per second. And that will be your answer, and that's the end of that one.